Hello, everyone. Good morning and good evening, dear authors and invited guests. Welcome to Technical Session 7B. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, New York, USA. The 10th edition of the conference is being organized in a hybrid mode. Both the physical event and the virtual event is being held across 2 days, that is 23rd and 24th of May 2025. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chairs. We have with us Dr. M. Shamim Kaiser, who is a professor at the Institute of Information and Technology of Jahangir University, Bangladesh. He has authored more than 150 papers in different peer-reviewed journals and conferences. His current research interests include data analytics, machine learning, wireless networks, and signal processing, cognitive radio networks, big IoT data, healthcare, neuroinformatics, and cybersecurity. We welcome you, sir.
Thank you so much. I'm here.
We also have with us Dr. Priya Pise, who is currently working Director Alumni Relations, Indira Group of Institutes, Pune, India. Her research area are big data analytics, cybersecurity, cloud computing, and data science. Her PhD is in the topic sensitive data sharing on heterogeneous platforms for privacy preservation. She has total experience of 18 years, including industry and academia. She has published 25 plus research papers in the various Scopus journals, HCI, UGC Care Journal, and conferences. We welcome you, ma'am.
Thank you so much.
I'd like to start with our paper presentations. Our first paper presenter for the session, I'd like to invite paper presenter Javed Mahmood with the paper titled A Multi-UAV Testbed for Real-Time Target Tracking Using Curiosity-Driven Reinforcement Learning. So if you're ready, then you may start with your presentation.
Yes, I will share my screen.
Yes.
So my project is the multi-UAV testbed for real-time target tracking using curiosity-driven machine learning. So my name is Jawad Mahmood, and the co-authors for this research study are Dr. Muhammad Adil Raja, Dr. Johan Leon, and Dr. Fergal McFerry. And I am from Dundalk Institute of Technology from Ireland. So the architecture of this project is based on actor-critic algorithm. So we have actor and critic. The actor is the neural network that will perform the action, and the critic is also the neural network, and it will evaluate the actions performed by the actor neural network. This framework belongs to the reinforcement learning, which is the subset of machine learning. And we have different sets of input and output to our models. The first set is like the inputs is velocity, acceleration, altitude, and the position of aircraft in X, Y, and Z axis. And the output we get is speed, roll, pitch, and yaw motions of aircraft. So here, this is the framework for our project. We have the flight gear, and flight gear is the realistic flight simulator, and we have JSB sim here. JSB sim is the flight dynamics model, and we developed the test bed based on these 3 models. The first model is the A2C algorithm, based on the A2C algorithm, which is the reinforcement learning algorithm. The second one is the A3C algorithm, and the third model is A3C plus ICM, intrinsic curiosity module. A2C is the actor critic advantage algorithm, and A3C is the asynchronous advantage actor critic algorithm. So we are sending the data from the algorithms to the JSB sim, and JSB sim is controlling the physical dynamics of the aircraft, and it is showing the simulation in the flight gear. In the similar manner, the flight gear is sending the data to the corresponding data to the JSB sim, and JSP sim is sending the control values to these reinforcement learning models. So this is the architecture of our algorithm, which is asynchronous advantage actor critic algorithm. We have policy network and the value function network, and we have different workers. We have worker 1, worker 2, worker 3, and we can increase the workers up to worker n, and each worker is corresponding to the individual environment. So each worker will explore the environment, and it will update the weights of the global network. In the similar manner, asynchronously, all the workers will update the weights of the global network. So this is the architecture for the tracking aircraft. For the target aircraft, we have A2C algorithm, which is based on this architecture only. So when we A3C is the building block of A2C is the building block of A3C algorithm. So this one is A2C algorithm. When we'll combine workers and global network, it will become asynchronous A3C algorithm. So here is the aircraft. You can see when it will rotate around the y-axis, it is considered the yaw motion, and when it will rotate around the x-axis, it is considered and the roll motion, and when it will rotate around the z-axis, it will consider as the pitch motion of the aircraft. So these motions are the output motions of our models. So this for to maintain the distance between the target aircraft and the tracking aircraft, we are using this methodology. So we are using the Gaussian reward function, and this is the mathematical expression for the Gaussian reward function. And the mu is the idealized distance between the two planes, two aircraft, and the sigma is the deviation from the ideal distance, and x is the actual distance, which is the input between two aircraft, and fx is the output reward. So here we are developing the ellipsoid around each aircraft by using this mathematical equation. So x, y, and z are the three axes, and a, p, c is the vertical perpendiculars, which will control this ellipsoid zone. So when the target aircraft and tracking aircraft will maintain the distance, the constant distance, we will get the reward. When the uh, tracking aircraft or target aircraft will move out of this ellipsoid zone, we will get the penalty. So the reward will decrease and the penalty will increase. When the target aircraft will come inside the zone, then we will get the penalty again to avoid the collision between two aircraft. So our main purpose is to maintain the constant distance between two aircraft. So this is the purpose of using this mathematical expressions, reward function and ellipsoid Gaussian reward functions. Now I will show you my experimental simulations of my project. So this is the experimental simulation when I will run the video. So here we have the target aircraft and we have the tracking aircraft. So this is the experimental simulation of the flight gear, and we have the pilot list here. This is the A2C, and A2C aircraft is showing the pilot list, and you can see the small aircraft here. It is the target aircraft, and this is the tracking aircraft. So this tracking aircraft is following the path of the target aircraft, and this experimental simulation we have recorded on the flight gear simulator. So when I will fast forward the video, so this is the Python code we have experimentally simulated. We have done the experimental simulation on the Python editor, and you can see this is the multiplayer chat window. So from the tracking aircraft to the target aircraft, we can send the chat. So for example, here I am writing something, and this is the chat window of the tracking aircraft, and when I will press the send button here, and it will transfer that text to the target aircraft. So look at here, when I have pressed the send button, it has transferred to the target aircraft this text. So this is the experimental simulation of my my project, and this is the Python code which which is based on the 5 different files, and you can see on the console we have the experimental data, which is this data is based on the A3C and A2C algorithm, and it is transferring to the flight gear, and we can also this is the Jupyter notebook, and it is controlling the A2C aircraft. So when I will fast forward the video, we can see here this is the Google map, which is connected with the flight gear. So here we have A2C and A3C aircraft, which is written, and we can validate the target tracking process by using this map, which is this Google map is built in with the flight gear. And this is the internal map of the flight gear, and we can also validate the target tracking process by using this map. Here we have the A2C aircraft, and we have the tracking A3C based aircraft. So we can also validate our task by using the internal map of the flight gear, as well as the Google map, which is linked with the flight gear. Thank you so much. Any questions?
Hello. Can you hear me, Javed? Hello.
Yes,
Can you hear
hello.
me? Yeah, can you hear me?
Yeah, your voice is very low. Like,
Is that okay now? Hello. Am I audible? Yeah, Javed, I wish to ask you, what are the primary challenges in a real-time aircraft target tracking compared to the, ground targets?
so real-time challenges in what aspects you're asking? Like,
I'm asking in terms of application of the, algorithm that you have tried to compare to the target, or maybe you can say altitude or speed or, trajectory of the aircraft.
so have you watched my experimental simulations now?
Yeah.
Yeah.
That itself was explanatory. Still, I thought, like out of
Yeah.
curiosity, I would like to know what are the primary challenges that you kept onto your mind.
So, like the real challenges in real world target tracking. So the real world drone, the existing drone we have, in that drones, we don't have the real time, the efficient communication between two aircraft. So we are using the machine learning, especially the reinforcement learning. This is the first time we are using in the drones the reinforcement learning. In the existing drones, they never used the reinforcement learning in the real drones. So what we have done, we have developed the intrinsic curiosity module. So the intrinsic curiosity module has increased the efficiency up to 10 times of these drones. So the existing drones which are available, they can do the target tracking. Especially in US, they have the most advanced drones, as well as the Turkey. So these countries, they have developed the drones which can do the target tracking. But our technique which we have developed currently in the software version, they can increase the efficiency up to 10 times. So by using intrinsic curiosity module. So how this module is working, this module is like our agent is based on the intrinsic rewards to generate to generate the decisions. So it is not dependent upon the external environment. So the current version of the drones, they are dependent upon the external versions, so it decreases the efficiency of the drones. So our aircraft, our model, they are dependent upon the intrinsic reward of the reinforcement learning models. Then they will generate the reward, the decisions, for example, the decisions about the roll, pitch, and yaw motions of the aircraft, how we have to maintain the distance between the target and tracker, how we have to maintain the altitude, the constant altitude, or the desired altitude. These all the decisions are based on the intrinsic curiosity module, based on the intrinsic rewards. So this is the major difference between the existing drones which are available in the market and the new technology which we have developed, which is currently in the software, and we have not implemented in the hardware. So we have the plan to implement this software in the hardware as well.
It will take you to the new stage of the challenges, maybe.
Yeah, it will, when we will implement on the hardware, then there will be the new challenges. Currently it is, we have experimented on the software which is a flight gear, but the flight gear, it replicate the real world environment,
I
whatever
have
the flight
I have
I
one
dynamic.
got it. I got it.
I have one
Thank you.
question.
Thank you. Best wishes to you. Yeah, over to you, sir.
The thing is, you have considered the environment is perfect, right? With
Yeah.
no latency and the interference, right? But in
Yes.
practical application, the communication delay, bandwidth constraint, and also the potential signal losses, this could also,
Yes.
I mean, they come into play. So how you will handle these things?
So, like in the real world environment, your point is like valid that we will get these challenges. So, in the flight gear environment, we tried to like introduce these challenges in the flight gear environment. For example, the weather changes. We try to introduce the weather changes in the flight gear, and the distance changes, the sudden distance changes of the target and trackers. So in our the next version of this research paper, we are currently working on the different research papers. So in the next version of this research paper, which is our paper is under review in the journal. So in that paper, what we have done the complex motions of the target aircraft. So we have introduced the complex motions. The target aircraft is moving randomly. For example, when sometimes it is moving in left, right, upside down. So this new challenge we have introduced for the tracker aircraft. So the tracker aircraft has done the brilliant job by using this intrinsic curiosity module based A3C model, that it has tracked the target aircraft. But in the real world environment, when we will implement this in the hardware, then we will come to know that what are the challenges we will face in the real world. So
Thank
currently we
thank
have
you so
tried
much.
our best to introduce the different scenarios in the flight gear environment, which this realistic flight simulator allow. So this flight simulator, it is used by the pilots currently in US also. The pilots use this flight gear for the training, to get trained of the like when they get ready for the flying, they get trained on this flight simulator. So this is the almost the realistic flight simulator which replicate our real world. But there are drawbacks of this flight simulator. Like we cannot say that it is like 100% replicating the real world, but it we can say it is like 99 or 98% replicating the real world. So there will be the real world challenges which we'll face when we will implement this in the hardware. That's all from my side for this question.
Thank you so much.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Ufuk Sanver with the paper titled Comparison of Deep Learning Methods for Detection of Psoriasis Lesions. Sir, if you're ready, then you may start with the presentation. Sir, Ufuk, if we have you here.
Hello.
Hello.
Okay. Okay. Now I find. Okay. Everyone sees, right? And, uh, hello. Comparison of deep learning methods for detection of psoriasis lesions. Ufuk Sanver and Mustafa Cem Kasapbaşı, other author. It is our agenda: introduction, dataset, use deep learning methods, results, conclusion, future work. Skin anomalies such as psoriasis and eczemas are common health problems in the world. With new computer vision and deep learning developments, automatic detection of skin anomalies from dermoscopic and clinical images has been significantly improved. There are lots of studies about it. In our study, it is aimed to compare accuracy rate of pre-trained deep learning methods at detecting skin anomalies which are caused by psoriasis, namely ResNet 50, EfficientNet B0, MobileNet V2, and DenseNet 201 are implemented and compared. These methods are implemented and compared. We have original and synthetic data. The original data, the data sets, our consist of visual images originally taken from psoriasis patient and data not containing psoriasis taken from different users. We have photos which are taken from patients who have this problem, and also photos who have not this problem. Original dataset containing 54 number of psoriasis cases and 32 not containing psoriasis, and then we created a limited amount of scientific data for this data. 11 data with psoriasis and 33 data for without psoriasis are created synthetically. We reflected images, random rotated. We used scaling, random scaling, and translation, random translation. And then at the end, with addition these synthetic data, the dataset is achieved 130 samples, and 4 different deep learning methods are used. EfficientNet B0 is the baseline model in the EfficientNet family, introduced to enhance accuracy and efficiency by adapting the network architecture. It uses a compound scaling strategy to balance depth, width, and resolution, improving model performance while maintaining computational efficiency. MobileNet V2 is an efficient and lightweight deep convolutional neural network design constructed for edge and mobile devices, engineered to improve beyond the original MobileNet by driving forward in accuracy without excessive computational cost. The architecture is based on inverted residuals and line linear bottlenecks, which implement both memory usage and inference rates. ResNet 50 is 50-layer deep convolutional neural network that is widely used for feature extraction and image classification. And DenseNet 201. DenseNet is convolutional neural network structure obtained by utilizing a large number of convolutional layers. These layers are sequential and combine data from previous layers and input them into the current layer. In addition, it is good at vanishing, which can achieve high-level success with a small number of parameters compared to other deep learning structures. And we used the known performance evaluation metrics. For validation, the results K-fold cross-validation technique is applied while obtaining the confusion matrix. Performance matrix, namely accuracy, sensitivity, precision, are computed using these equations. And results. We used the MATLAB 2024B on a machine equipped with 16 gigabyte of RAM, Intel E5 3 GHz CPU, and Microsoft Windows operating system. Five-fold cross-validation, each fold trained for 15 epochs. Average of the metrics are calculated. 13 examples for each group with psoriasis and without psoriasis are selected as test data. We had 130 data and 26 are selected as test data. In each fold, different pictures are selected as test data. And results for DenseNet. DenseNet 64 actual positive and 1 actual negative. EfficientNet 63 actual positive, 2 actual negative, and actual positive but predicted negative 5. In next table, I can show results. Next, here better about metrics. At the end, if we compare the main goal of the study was the compare of these methods and select and decide which of them is better in this problem. DenseNet 201 has 99 more than 99% accuracy, 98% precision, and EfficientNet B0 92.62 94.62% accuracy and 96.92% precision, and MobileNet 93% approximately accuracy and precision 90%. ResNet 50 94.62% accuracy and approximately 90%, 89% precision. It is shown here that DenseNet has better results in this problem. But we also noticed the average training time of explained deep learning methods, and DenseNet 201 1020 seconds, EfficientNet B0 140 seconds, MobileNet V2 92 seconds, and ResNet 50 205 seconds. In this computer, we tested in all of them in same computer and same condition. The computer did not do any other work, only worked for this problem. If here we can see that if we need to have a faster solution, then it is better to use efficient bet V0 or MobileNet V2. But if we have a strong machine, strong computer, or we have and or you can say time, then DenseNet give us better results. The results of the experiment showed that DenseNet 201 performed better than the other models in all the metrics used for evaluation. It is due to its architecture design and feature reuse. MobileNet V2, however, was identified to be the quickest train due to its relatively fewer layers and smaller numbers of trainable parameters. And our future work goals work together with a dermatology doctor and of course with ethical permissions and collecting different data and have a bigger data set. And also we our another goal is to compare the accuracy ratio also with different pre-trained deep learning methods. Thank you for listening.
Thank you so much. I have just a small question. I mean, have you done any parameter optimization?
Yes, we use it ADAM
Hyperparameter
optimization.
optimization, right? Have you done this?
Yes, and SDGM optimization.
Okay, okay, thank you.
Yeah, I have a question. How did the dataset size and the quality of the images affect the performance of the models that you have compared?
How we take images?
Yeah. Dataset
Uh,
size and the quality. Does it
uh,
matter?
okay, I had this problem,
Mhm.
but no, I am better. But December, November, these months, I had very strong, and the patient was the data with psoriasis, and without psoriasis, our colleagues we used, and we take photo mostly from head and these regions. Of course, this problem is in all body. It can be psoriasis, but to work with data unknown patients, it is needed to take ethical permissions and work with doctor. Yes, it is our future goal.
Okay, and how did you do the annotation?
How did we?
Do the
Could you
annotation for the images?
notation? How we this? I was in. How we know that this is problem psoriasis?
Hmm.
It is the
Hmm.
question. Or
Right.
yes, I was in doctor and doctor said psoriasis and there are different types. For example, crusted or not crusted. These lesions are different types.
Okay. Thank you.
Thank you very much.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Diego Perez Lopez with the paper title Deep Learning Based Stacking for Recommender Systems. So if you're ready, then you may start with the presentation.
Well, I'm gonna share my screen.
Sure, sir.
Can you see it?
Yes, sir, it is visible.
Okay. Good morning, everyone. My name is Diego Perez, and I'm very happy to be here today to present our research deep learning based for recommender systems. Here is the agenda of this presentation. Recommender systems are tools that help users discover content they might like. They are used everywhere. When you watch a movie on Netflix, shop on Amazon, or listen to music on Spotify, you are using one. There are three main types of recommender systems. First, demographic filtering, which uses things like age, location, or occupation. Second, content-based filtering, which recommends items similar to those the user liked in the past. And third, collaborative filtering, which is our focus. It suggests items based on the preferences of similar users. For example, if you and I liked the same movies and you liked a new one that I haven't seen yet, the system might recommend that movie for me. So let's take a closer look at collaborative filtering. The main idea is to use the experiences of users who have similar tastes. We start with a big matrix where each row is a user and each column is an item, like a movie. When a user gives a rating, we fill in the value. But in reality, most of the matrix is empty because users don't rate everything. Collaborative filtering tries to predict those missing ratings to decide what to recommend. There are two main ways to do this. Memory-based methods use the rating from similar users to fill in the gaps. Model-based methods, on the other hand, use machine learning to find hidden patterns. One of the most popular model-based methods is matrix factorization, which creates two smaller matrices that represent hidden features of users and items. By combining them, we can estimate the unknown ratings. While collaborative filtering is powerful, it also has some important limitations. One big issue is that no single model works perfectly for every user or item. Some models might perform well with certain types of users, especially those who have rated many items, but the same model might do poorly for users who have rated very few things or for less popular items. In addition, its model tends to be good at capturing certain patterns, but not all. So if we rely on just one model, we might miss valuable information. That's why we started thinking, what if we could combine different models and let the system decide which one to trust more, depending on the user and the item? Our idea to solve this problem is called neural stacking. The basic concept is to combine the predictions of several collaborative filtering models using a deep neural network. We use four base models: PMF, biased MF, NMF, and BNMF. Each of them makes its own prediction for a user and an item. Then we feed all this prediction into a neural network, along with the user and the item IDs, which are encoded using one-hot vectors. The network learns how to combine the models in a smart way. For example, for one user, the system might give more weight to biased MF, while for another, it might prefer BNMF. This makes the final recommendation more personalized because the model adapts its strategy depending on the specific situation. Now I'll explain the architecture of our stacking models. We create four different versions: neural stacking 1, 2, 3, and 4. Let's start with the first two. In both cases, the input to the neural network includes the one-hot encode, user, and item IDs, and the predictions from the four base models. In neural stacking 1, multiplies the prediction value by its weight and adds the user's weight and the item's weight. In neural stacking 2, we add one extra weight parameter in the final layer. This small change allows the model to better adjust how much its model contributes to the final prediction, making it more flexible. Now let's look at the other two versions, neural stacking 3 and neural stacking 4. These models are more advanced in two ways. First, they use a multiplicative approach. Second, and very important, they change how the input layers are structured. While models 1 and 2 use a single shared layer for both users and items, models 3 and 4 use separated layers. one for the user and another one for the item. This allows the model to learn more specific patterns for each type of input. So both are deeper and more flexible, and thanks to the multiplication strategy, they can capture more complex iterations. This is neural stacking 3 with the extra individual layers for the users and items. In this case, the weight of the user and the item multiply instead of adding. Finally, neural stacking 4, similar to neural stacking 3, but adding that extra weight in the final layer. So to summarize, models 1 and 2 are additive, while models 3 and 4 are multiplicative, adding that extra layer. To evaluate our models, we use the MovieLens 100K dataset. It contains around 100,000 ratings from 943 users and 1,682 items, like movies. Its rating is between 1 and 5 stars. We split the data into training and test sets using the same setup provided by the CF4J library. To measure accuracy, we use two common metrics, MAE, which stands for mean absolute error, and MSE, or mean squared error. We also tune all the hyperparameters using grid search and five-fold cross-validation to make sure the comparison was fair across all models. Finally, we train our neural network with different learning rates and number of epochs to find the best configuration. Before testing our stacking models, we compared some well-known baseline models. Among the major factorization methods, biased MF and BNMF gave the best results. Biased MF had the lowest MAG, which means it made the smallest average error in predictions. On the other hand, NMF performed the worst. Its restriction to non-negative values made it less flexible and less accurate in this case. We also tested deep learning-based models like GMF, MLP, and NeoMF. These models performed reasonably well, but still didn't beat biased MF. So even though deep learning is powerful, traditional models can be still competitive. Now let's look at the results of our stacking models. The best performance was achieved by neural stacking 4 with the lowest MAG of 0.753. That's better than biased MF and also better than the deep learning models like NeoMF and MLP. The other three stacking models also show strong results, especially neural stacking 1 and neural stacking 3, which were very close in accuracy. What this tells us is that combining models, even simple ones, can lead to better recommendations when done in the right way. Our neural network learns how to weight its model's prediction depending on the user and the item. To wrap up, our experiments show that neural stacking is a very efficient approach for improving recommendations. By combining different collaborative filtering models and letting a neural network decide how much to trust each one, we get more accurate and personalized results. Among the traditional models, biased MF and BNMF were the strongest. Among the deep learning ones, MLP performed best. But all of them were outperformed by our neural stacking 4 on the MAE metric. For future work, we plan to improve the network architecture even more and include contextual information like user behavior over time or item categories. We also want to test this method on larger real-world dataset to see how it scales. Thank you so much for your attention. I'm happy to answer any questions.
Daiko, I am curious to know what are the application of your research, or the work that you have presented today.
The application, for example, PMF, probabilistic matrix factorization, was the best recommender, and Netflix, the platform of streaming, paid around $1 million to get better recommendation for the clients, because if you have the best recommendation of a client, that means that you can get more clients for your platform, and that means benefits for the business.
Okay, thank you.
I have one question. You use stack, I mean the deep learning algorithms, right?
Yes.
So the stacks algorithms suffer from, I mean, the delay problem. So sometimes the real time, I mean, recommendation will not be possible for your case, in my opinion. What is your, I mean, concern about this question?
Do you mean that the recommendations?
Recommendation delay.
Yeah. In this case, we pre-trained the data to have the model pre-trained to low the cost of time with that problem. But that's true. These type of recommenders are a little bit slow, and we try to pre-calculate the recommendations for each user previously to to show that the recommendation for the user. But
Thank
that's
you.
true.
Thank you.
In real time, that will be a problem maybe.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Ujjwal MK with the paper titled Emo Health, a deep learning fusion of speech and body parameters for real-time emotion detection and health analytics. Sir, if you're ready, then you may start with your presentation.
Yes, thank you for the introduction. I would like to go and share my screen.
Sure, sir.
Yes, is my screen visible?
Yes, sir, it is visible.
Okay, thank you. So yes, welcome everyone. So our project is Emo Health, which is a deep learning fusion for real-time emotional and health analytics. So basically, why are we even trying to do this is basically in this fast-paced society wherein people are just going about their day. What we try to do is we don't want to be up in front of their face, and then we try to analyze how their emotional well-being is from the background in their day-to-day activities, either through their video call or voice call, or maybe how they interact with their surroundings and so on and so. So emotional health is deeply connected to physical well-being, as we all know that. So what is happening currently is whatever applications are out there or any methodologies that are out there, they only rely on single modality as of now, which means like they either try to see your facial expression and try to say how you are doing, or they sometimes struggle with some variability such as like noise or like limited context in what's happening in your life. So they don't really give a good health monitoring feedback to you, and there are often many applications which are in this field, which in the field of health monitoring do rely on lab environments and then heavy equipments. So these are the certain limitations that are there as of now. So we are trying to come up with a solution wherein we try to overcome some of these limitations on some level, and then maybe go for a better health monitoring system over here. So what is the methodologies that we are using as of now? We want to surpass single modality and then go for multimodality over here. So we are currently utilizing psychological signals and then speech signals as of now. So psychological signals, some of the examples could be heart rate variability and then GSR values and then respiratory rate, sleep data, so many things which are related to a particular person. And then speech emotion itself is self-explanatory, wherein the person, the way they speak, the pitch, the tonality, the amplitude, frequency, everything is captured in it, and then we try to analyze their emotion through it. So as of now, the gaps addressed by our application, so-called Emo Health, is that the accuracy drops in an uncontrolled environment, and there is lack of real-time on-device emotion inference, and there is weak or no multimodal integration. So we are trying to address all these solutions, address all these problems by providing a solution. So if we see what is this, it's basically a mobile application that we are implementing over here, which helps with real-time emotion recognition and health monitoring using wearable tech. So wearable tech as in we are currently using Apple Watch and then an iPhone, which are all Apple products, which do communicate with each other through Bluetooth or their own internal message passing technique. So what is the key innovation we are doing here? As I mentioned, we are doing multimodal detection utilizing both speech and psychological signals. And the latest thing that we are trying to do is, while there are a lot of APIs available wherein the data can be sent over to a public server or another private server, we are trying to do on-device analytics wherein each individual's data is not at all sent anywhere and it's private and local to the user, and it also leads to faster execution. Then personalized insights into emotional and physical well-being, because the data that is being collected and stored on device is only related to that person. So of course, it's going to be more personalized. So the tools we have used over here is Apple Health Kit and Core ML and Apple Watch and iPhone. Apple Health Kit over here is basically a framework or a methodology provided by Apple, wherein all the health data related to the person is just stored over there. And then Core ML is a framework provided by Apple again, wherein it helps with machine learning development and inferencing on device across various Apple products. Moving on to system workflow. So as we can see the diagram over here, so we start off with data input, wherein the Apple Watch collects the psychological signals. Some of the examples that I already mentioned are heart rate and then respiratory rate. And then next comes the data collection layer, wherein it synchronizes the data and then processes the audio being collected from the mic, of course. And then the model inference layer, wherein it analyzes the data to predict the emotional states. So it uses both the psychological signals and the audio data coming from the mic, and then analyzes what the emotional state of is at the current instant. And then we are applying some kind of fusion strategy wherein it combines both the predictions such that it provides a single final outcome. And this final outcome is basically classified as into an emotion at the last stage. Then comes the user interaction and feedback, wherein it displays the real-time emotion state and along with multiple other health metrics. And finally, we also provide local storage over here, wherein the data is saved locally for privacy concerns, as we don't want any access to users' personal information. So here on the left side, you can see the data sources are Apple Watch sensors, which are already pre-built, and then iPhone's microphone. Then data collection is done through Apple's Health Store Manager and audio processing. These are the backend functionalities which are implemented only for this application. And then the analysis is done over the Core ML, which, as I mentioned, is a framework provided for developing machine learning models on device for the Apple products. Then visualization, we are utilizing certain types of heat map and then graphs to just visualize how the data is changing throughout time, so that the user has a more intuitive approach on what to do in certain situations. So coming to the data sets, we try to use various kinds of data sets so that our machine learning models, which we develop over here, are robust enough to handle any kind of demographic situation. So we use test data set, Travis, CREMA-D, then moving on Savvy, Life Snaps, and then PM data. So as you can see, they are across like various demographic situations over here, collected from various actors in a particular kind of situation. So the description of each of them are provided so and so. Then moving on to the data preparation. So the data which we got, as I mentioned over here, the couple of the data sets that I mentioned over here, they can't be used as it is provided. So we did some kind of data preparation over here, or like pre-processing, if you may. So wherein the psychological data, where we ended up doing some kind of feature selection and then data cleansing, label alignment, data transformation, validation, and structuring. And on the speech data set, we had like multiple speech data sets, about 4 or 5, wherein we had to do some kind of data aggregation to bring in all the emotions into one class, or like in one structure or one directory, and then the emotion labeling for those, and then the data structuring, as I mentioned now, and then encoding and validation. So going deep into those, so basically data aggregation is we had these MP3 and WAV files. So we had to like form proper structure of those files. And then the emotional labeling, wherein the extracted emotion labels from folder names or encoded file names map to like the numerical classes. And then we also had to do some kind of data structuring, wherein the paired audio parts with labels formatted for feature extraction. Then we did encoding and validation. And coming to the psychological data, we did feature selection because we chose parameters like heart rate variability, respiratory rate, sleep data, steps, activity calories, which are usually related to one specific person. Then we did data cleaning and then label alignment. And also the data transformation, wherein we had to like normalize the values and then encode the values into other formats. And we also did validation and structuring. So, and then moving on to the next topic. So this was one of the models which was used for psychological data. As I mentioned, psychological data, we chose multiple parameters like heart rate, sleeping data, and then respiratory rate. So what was the reason for using random forest? Because a random forest is very good at handling missing values, and then it captures nonlinear relationship, and then it is robust for overfitting and noise values. So it is ideal for real world values. So next, as I mentioned again, it's repeated over here, wherein the features used mentioned heart rate variability, respiratory rate, age, gender, BMI. So we used around 11 to 12 parameters, which are closely personally related to a particular person. And then the data preparation pipeline. So we cleaned and normalized the psychological metrics. We imputed missing values, aligned mood logs with biometric patterns, encoded demographics and structured training arrays. Then training approach, what we did was we trained on those live snaps and then PM datasets. So, and then we used the core ML framework using the Create ML application again provided by Apple for model tuning and deployment. Then we were able to deliver accurate personalized prediction with minimal latency. Since this dataset was captured and then it was cleaned beforehand, we were able to get very good results with this one. So this is just the 50% of the entire model fusion strategy, because we still have to go over the speech model over here. So moving on to the speech model. So this speech model is based on a VGG-ish architecture. It's a CNN model. So before utilizing this model, we had to convert the audio wave files that we are utilizing into a MEL spectrogram using MFCC algorithm. So MFCC is used for reducing sensitivity to accents and dialects. So it mainly focuses on what is the underlying emotion in it. Then moving on to the training data, as we mentioned, it's aggregation of RAPDES, TEST, CREMADI, and SAVI, multiple data sets which are covering various demographic areas. Then audio files which are paired with emotion labels via folder or file name structure, which was already previously done. Then it was validated and encoded for the core ML processing. Then how did the training happen? So we used Adam optimizer, and the loss function was categorical cross entropy for multi-class classification. And the multi-class here being we used we predicted across 5 different classes. And then it ran for about 84 epochs, giving us a 94.5% training accuracy and 94.4% of validation accuracy. And we were happy to announce that there was no
I'm really
overfitting
sorry to
observed over here.
disturb you, but I'd like to remind you of the time limit.
Okay, thank you so much. So, and then moving on, this was again done in the core ML format itself. So the fusion mechanism happened so that it was a late fusion mechanism wherein 2 separate models were later fused together to provide a single outcome. So this enables the models to learn separately and then finally give a single output. So that was the only reason why we did late fusion instead of an early fusion. Then moving on to the final inferencing over here, we can see that the network utilization is completely zero. We are doing it on device itself, and the memory utilization is all very minimal to the latest trends. And moving to the user interface, we were able to develop a simple user interface along with the heat map, which you can see there, which is very intuitive to the user, wherein they will be able to see what's happening and then they can take the necessary action. So the final summary and the conclusion that I would like to say is it enables continuous emotional monitoring in real world setting. And then it supports early detection of stress, anxiety, and mood disorders. And it integrates seamlessly with the latest health platforms across various organizations. And it offers privacy preserving health analytics. So what we would like to do next is we would also like to develop an Android equivalent of this application, as this is completely on the Apple platform. And then we would also like to explore federated learning, which is a form of decentralized learning, and then maybe even investigate into hybrid future techniques. So thank you. I'm open to any questions.
Ujjwal, I really appreciate the work you have done. Out of curiosity, I just have a question to you. Like, do you have any recommendation through software upon analyzing? I have understood your complete cycle, gathering the information, applying the technology onto it, testing, and finally analyzing. So, any recommendation for a person who is suffering a mental health issue?
As in, I'm sorry, I didn't get a question correctly.
See, you are trying to have complete balance between the mental and physical health, right?
Yes.
Yeah, you're trying to
It
analyze
basically
that. So a
captures the
person,
data. Yeah.
so after capturing the data, if your analysis says that a person has got some mental issue, so is there any recommendation for him? Because that's how the loop is going to get closed, in my opinion.
Yes. So basically, what this happens is there's also one last step to this, wherein a notification is sent from the app in a timely manner. So assume there's a notification that says you are being overstressed, and then it also suggests what you can do. In that message, we currently have involved certain kind of steps that the person can take on their own, or else it also helps them contact the nearby doctor or their family friends, something like that, who can assist them later on. So that's the initial steps that we would like to assist with them.
Okay. Okay. Best wishes.
Thank you.
I have only one question. How
Yes.
you have actually fused two different types of data?
How have we fused the data, or how have we fused the
Yeah.
model
I
at
mean,
the
the
end?
which level? In the data level or the knowledge level? Fusion.
The model, the predictions at the end are fused on the model level. The data is being sent separately, so they are not
Okay,
fused.
okay, got it. This is a knowledge level fusion.
Yeah.
Thank you.
Thank you.
Thank you, sir. We will be proceeding with our next paper presenter. I'd like to invite paper presenter Matsutwa with the paper titled Ethical AI Adoption in South African SMEs Using a Contextual Framework. Ma'am, if you're ready, then you may start with the presentation.
Thank you. I would like to share my screen, please.
Sure, ma'am.
Okay, please let me know if you can see my screen.
Yes, ma'am, it is visible.
Thank you. Let me just put it on presentation mode. Okay, so my name is Connie Confidence Hlatswayo. I am a PhD candidate at the Valley University of Technology, working on a project on ethical adoption of AI by South African SMMEs. Let me just get this out of the way. Thank you. And today I will be presenting my paper titled Ethical AI Adoption in South African SMMEs Using a Contextual Framework. And these are the contents of my presentation, the background and in motivation, theoretical frameworks, the conceptual framework that we came up with, our findings, some of the proposed strategic frameworks, limitation, as well as the takeaways from the study. So AI as an extension of ICT offers immense potential. It offers immense and potential benefits as it enhances businesses' operations by automating routine processes, optimizing their decision making, as well as improving productivity, which then improves the overall performance of the organization. However, despite all these advantages offered by AI, there is a need for structured governance as well as ethical frameworks in order to ensure that fairness and transparency is then achieved. When it comes to South Africa, it is one of the slow adopters, although there is the potential to transform businesses by AI. South Africa is lagging behind in adoption because SMMEs in South Africa have financial constraints infrastructure constraints, and therefore, and as well as digital literacy. And therefore, this then tends to make SMMEs hesitant towards adopting the AI systems. And there are some key ethical issues also that poses a threat. These include algorithmic biases, data privacy violations, as well as transparency issues. These tends to pose barriers as well as for responsible AI, which then makes SMMEs struggle to adopt and embrace these technologies. Now, the study then aims to address these gaps in research, especially the AI, when it comes to integration. While there has been increased attention on AI development and how it is adopted within businesses, there is very little research that focused on the ethical integration of AI within SMMEs, particularly in South Africa. There has been quite a few studies in Europe, but South Africa, there has not been, hence we undertaken the study. Therefore, we then, having analyzed the literature, we then came up or developed the contextual framework that will then align ethical principles with SMME specific challenges and therefore offer guidance while they are attempting to adopt AI. And just to give a contextual background, there's just context in South African context when it comes to SMMEs and AI. SMMEs in South Africa, about 90% of formal businesses in South Africa are SMMEs, and these businesses or these SMMEs account for 60% of the labor force and contribute 34% to the GDP. And as I said previously, these SMMEs, many of them operate in resource-constrained environments, and therefore ethical issues tend to be ignored, especially when businesses attempt to undergo digital transformation. So when it comes to the, I'm sorry, I just want to get this out of the way so I can get the presentation. There we go. So when it comes to our theoretical framework, the study then used or applied complementary theories, theoretical lenses, which looked at the TOE, as well as EDM. Together, these frameworks then provided us with a coherent foundation, which helped us categorize the drivers, the barriers, as well as the ethical consideration for that then influence SMMEs to adopt AI systems. Now, the TOE was selected among many technology adoption models because of its robustness and because it offers a holistic look at the organization, taking into consideration the technology, the organization, as well as the environmental factors. Whereas the so the TOE, from the technological context, we then find that complexity, compatibility, as well as perceived benefits, these are factors that tend to influence SMME's perception of the feasibility of AI systems as well as its trustworthiness. From the organizational perspective, things like size of the organization, a leadership commitment, as well as the skills of the employees, and most importantly, financial resources. Those are critical issues in determining the readiness of SMMEs to adopt AI systems. And when it comes to the environmental context, things like regulatory support, industrial standards, as well as the market competition or competitive pressure and the socioeconomic factors, these then they can either facilitate or hinder ethical adoption, particularly in developing economy like ours, especially when it comes to socio-economical factors in South Africa. So the EDM then, as a complementary theory, was selected amongst the other ethical frameworks because it focuses on the moral awareness, the judgment, as well as the intent and the behavior in AI decision making. So that's why we use then these two frameworks. Now this is a graphical representation of TOE. And this is a graphical representation of our conceptual framework, which we then developed, having analyzed the literature and found some of these barriers and the influences that affect SMMEs or that influence SMMEs to adopt AI systems. Some of our key findings from the TOE perspective, we noticed that the more complex the technology, that tends to hinder the SMMEs in adopting the application. So high complexity translates to low trust. And because the infrastructure also is not so good in SMMEs, especially in South Africa, that then hinders the adoption. From the organizational point of view, we notice that lack of leadership commitment, as well as low ethical awareness and digital skills shortages, those tend to influence or hinder SMMEs to adopt these technologies. The environmental perspective, with things like policies and minimum regulatory support from the regulatory bodies, tend to hinder the adoption of SMMEs. And South Africa is still very in its early stages when it comes to policies and guidelines as far as AI systems are concerned. The key findings from the EDM perspective, we found that there's issues of privacy and data protection. There's concerns and of misusing data, because you have to relinquish a lot of your personal and private data into the system in order for the system to work effectively for you. And so SMMEs tend to be very skeptical. And the introduction of the POPI Act, which is the Personal Protection of Information in South Africa, also made things a little bit more complicated in that area. And then transparency and accountability. When the system is considered to not be transparent, or is considered to be like a black box, that then tends to hinder the responsibility, which affects the SMME's perception of the whole system. The low morality intent, SMMEs then lack the tools as well to assess and address ethical concerns. And the big one we found was the threat of job displacement. These AI tools, because they automate a lot of routine routine practices within the organization, it then poses, or it can lead to job losses, which then raises the ethical concern about economic inequality. And this is a big one for South Africa, because we I think considered the highest, we have one of the highest inequality and unemployment rate in the world. And therefore job displacement or job losses is a real threat to the South African economy. And these are then the proposed strategic framework, which we have then suggested having this having analyzed literature and identified what some of the challenges are. In the interest of time, I will not go through all of them, but one that we found that was came out a lot was the fact that post-adoption issues. Many of these organizations will then buy these systems, adopt this system, put them in place, but there is no support after having the system done. And the other thing was the training that happens. So training is very important in order to make sure that the organization is ready for the system. And some of the limitation for this study, because this is a review study, the study relied heavily on literature review, which then means there is no first-hand data from South African SMMEs to then show the practicality and the challenges and the strategies that they are facing while trying to adopt this AI system. And their focus on South African SMMEs, it offers a localized insight. However, the findings of this study can therefore not be generalized to other economies, especially developed economies, because they're all economies that have a different social economic challenges as well as technological challenges or landscape that are different from South Africa. And regular updates to the proposed frameworks are necessary, and this is just to make sure that the relevance of the framework continues to be updated, because the dynamic of nature of AI technologies keeps evolving at all times, and therefore, which means the ethical concerns will also evolve along with it. And some of the takeaways that we got from this paper, the study, is that ethical adoption is not just an issue of it's not a technical issue only, but it is contextual, and it also involves moral obligation and ethical obligation. And we also found that SMMEs with strong ethical intent and governance are better positioned. Therefore, they are more likely to adopt the AI systems. And a dual lens framework from the TOE and the EDM provided us with the practical as well as the scholarly guidance for us to conceptualize a framework for that encompasses both. And also aligning digital strategies with ethical imperative is also important for responsible innovation. And one of the biggest takeaway that we found is that rather than just adopting a system or an AI tool, SMMEs should then focus on reskilling or upskilling their employees, and as well as promoting human and AI collaboration rather than replacing the human element with the AI system. Thank you very much. That will be the end of my presentation.
Kuni, I have no question for you. Thank you.
Thank you.
Thank you so much. I don't have any question.
Thank you very much. Thank you for the opportunity.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presentation. I'd like to invite paper presenter Elrash Sheikh Ismail with the paper title Payload Identification Patterns Across a Saudi Sample of Cybercrimes by Recruiting Powerful Classifiers Competencies. So if you're ready, then you may start with the presentation.
Yes, let me share my screen.
Yeah, sure, sir.
For the delay. And good morning, good afternoon, good evening, everyone. I'm panel here. I will introduce my presentation. Sorry, I'm facing shareability problem. Just a minute to adapt my presentation. Is it clear?
Yes, sir, your screen is visible. Please go ahead.
Okay.
Our article, sorry, my name is Rashid Ismail Mahmoud. I'm a lecturer at University of Bisha, Saudi Arabia. Our article, payload identification patterns across a Saudi sample of cybercrime by recruiting powerful classifiers competence. Our main goal for this study is to test machine learning classification analysis across a rich network traffic sample dataset to figure out patterns of the Saudi cyberspace and alert the community for cybercrime risk. This slide outlines the topics that I'm going to introduce. The data value, as we know, this slide presents or gives a sample picture for our data sets and the value for the data set. The data identify cybercrime risk, require collecting a real sample data. Also, the value for the data when analyzing cybercrime data, analysis will offer us right information about the features that affect or affect a cyber space status for the region or for the country. The data are very valuable for developing and managing and strengthening the career of security anywhere, anytime. Our data set, this slide shows the amount or the size of our data sets. We get a cybersecurity data set from Jazan University for a period of time. The sample data sets consists of 150 rows, 50,000 rows with 67 columns. This is the dimensions and the interparameters for the normal traffic data sets. The demographic feature for the dataset could be one of these types, one or more, or hybrid kind of these types. Data can be numeric or mapping or sequence or a set of datasets or Boolean or hybrid set of datasets. This table gives some statistics for our datasets. Here, we would like to forward our thanks for the Deanship of the Scientific Research in Jazan University because for their funded this project. Cyberspace, the definition for the cyberspace is a digital environment globally connected via interconnected infrastructure networks that seek to enable participants communicate in a secure way. Defining cybercrime, this slide gives word cloud for the major cybercrime risk. As we see, cybercrime risk can be spam or phishing or smishing or vishing or malware, security, maliciousware, spyware, data leakage, AI trends, spyware, adware, and so on. Yeah. And any for the time concentrate, we can guess the definition for each of these risks. The study examine traffic network sample data sets for the Saudi country. The Saudi cybercrime, Saudi cybercrime risk or the Saudi space challenge can be can be listed as growing issues with online fraud, identity theft, and data breach, difficulty in tracing and prosecuting criminals, high demand for specialization and training education in cyber defense and ethical hacking, growing concerns over how private and public sensitive data is handled. We collect several related work to figure out the research gap, and this table we summarize this table by figuring out the research gap in this following these three questions. Research questions. How do machine learning classifier represent the payload trends in Saudi network traffic linked to cybercrime? Which major themes predominate in the data sets? Discussion of cybercrime. What effect may these findings have on cybercrime policy and public awareness? Our methodology can be summarized as this figure. First, we collect a rich sample for cybercrime data sets. Then we pre-process these data sets by controlling the noisy data and missing data and feature selection and feature extraction. Then examine a lot of classifiers, and based on their performance, we headed our targets. Classifiers metrics, performance metrics can be summarized as AUC and confusion matrix, or scalars as accuracy and error F1, and so on. Classification, machine learning classifiers are the first candidate methodology that could be used to assess cybercrime threats across the country. The study process a rich sample and examine a popular classifier's competency. Cybercrime dataset assessments address the problem and help design suitable innovation. So classification metric can be classified as visual metrics and scalar metrics. The visual metrics can be AUC and ROC, confusion matrix, shape value. The scalars one can be accuracy, errors, F1 score, precision, and recall. Each kind of these classification metrics has advantage and disadvantage. For example, for the visual metrics, the disadvantage is the cost and procedural. And for the scalars one, the disadvantage are authentication and confidential. We employed for our dataset, we use Python and we employed a correlation coefficient to figure out the contribution for each feature, and this is a sample output for the correlation coefficient for the data sets. Here we can notice the contribution for the features per model and per each, and the metrics can be like that. If the features contribution is near to 1, it will be good, or above 0.5, it will be okay, and can be sorted out to the next step for the pre-processing, else can be discarded, and so on. This slide outlines the features impact. You can see we have, as we see in the second slides, we have 67 different features. Out of them, we can see inbound interface, and source zone, and destination addresses, and source address, and destination country are the key impact features. This slide gives the highly contributed features and ranked. Yeah, if you see, if you have a look for the slide, we can see the destination address is the big contributed feature, followed by streets, followed by destination zone, and risk applications, and flags, and inbound interface, and so on. If we took the features, source and destination features based on the country as a target for the data sets that we capture, the data sets, this country appeared on the data set. If I maximize the slide, we can see the names of the countries that exist. For the result, this is a real sample for a single model output. It concludes the summary of the performance of the model. As we see, the values for the balance accuracy for the training phase and for the testing phase, 1.95 or 96. F1 score values for the training values and for the testing values. And this limited table 2, summarize the performance for the top precision values for 1 and 2 and 3, 4, 5, for the 5 different classes. And we can see the values for the core F1 score and support. Support means the supportive records for the data sets. Supportive records for the per the class, and the accuracy values and macros and weighted. And these are the keys. Here are some examples for the visual metrics. We use confusion matrix.
Sorry to disturb you, but I'd like to remind you of the time limit.
So 1 minute, I will.
Okay.
Confusion matrix. This confusion matrix is a visual output metric and rock curve for the 6 classes, top 6 classes, and table 1 gives, table 2 gives the most. Compare the models, as we can receive 5 different models based on accuracy and balance accuracy, F1 score, and time taken. Then from here we can optimize which is the best, and it is easy. And here the classifiers response based on the accuracy with respect to dropout. We can see bagging algorithm and take the best, and decision tree, and the random and tree based on the dropout. Those are some samples for cybercrime. We can see spyware, unknown, brute force, DNS, and so on. Here are the discussions. First, we gather the data set, purifies the data set, clean it, and let it available for the scholars for reuse. Second, we use LedPredict to nominate the models. The third, powerful machine learning computation algorithm were performed. Finally, classification model performed, and the performance metric based on the performance metric, particularly accuracy and balance and F1, and learning time taken, confusion matrix, and based on the destination, DTE, decision tree classifier, was the best, and the Saudi was the 9th country as the generated target, source target, so the prime source target. This is our conclusion. We collected this sample data set, purified it, and made it available and shareable. Examine machine learning The limitation, this sample study is only based on Kazan University. The next, the futuristics for the study will be for the whole country. References and video answer. Thank you for listening. I'm open for questions.
I think it was in-depth discussion, so good to go. No question.
Thank you. Thank you very much.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Vindhya with the paper title Plant Ease Explainable AI for Cinnamon Disease Detection. So if you're ready, then you may start with the paper presentation.
Yes, thank you. Can I know whether I'm experienced with that, please? Can I know whether I'm experienced with that?
Yeah, sir, it is visible.
Okay, thank you. Greetings, everyone. My name is Vindhya Vikramatunga, and I have co-authored this paper with Ms. Sapna Kumarakatirage. It is called Plant Ease, and it is an explainable AI approach for cinnamon disease detection. This will be our agenda for our presentation. First, I will give a brief introduction into our problem background. So, over 2.2 million tons of cinnamon were produced globally in the years 2021 to 2022. And cinnamon is a major export crop in Sri Lanka because of the high respect for the quality of Ceylon cinnamon around the globe. And therefore, it is important to make sure that the cinnamon production in Sri Lanka is not affected by diseases that it is vulnerable, which will reduce its quality and its yield, resulting in a loss for its farmers. Currently, the methods of detecting diseases in cinnamon is the visual inspection by trained experts in the field, as well as farmers with a long time of experience. And this method can be time consuming, and the decision of the inspector could be subjective. And even if it is an experienced inspector, it can often be inaccurate when detecting in its early stages. With the advancements in technology, there are many methods introduced of detecting diseases in plants. Some of them are object detection algorithms and deep learning methods. From deep learning methods, CNNs in particular have shown great success in identifying the diseases from the provided images. But while the decision given by these models may be accurate, they do not tell the user why a decision was made. And with our target end user being farmers, most farmers can be considered as non-technical users. And therefore, they might be having some doubt when an application gives them a decision. And this could cause trust issues and hinder the adoption of these technologies in the agriculture domain. This black box issue of CNNs and deep learning models can be solved with the integration of explainable AI, as it helps to provide visual explanations of the decision of the models by providing a heat map highlighting the significant areas contributing to a model's decision. So, through our literature review, we were able to find that there were many XAI methods used when detecting plant diseases. And the most prominent ones were GradCam++ line. And GradCam++ stood out as it is in itself an improvement on technique like GradCam. But while these methods have been implemented heavily, they can create blurred and less accurate heat maps. This is due to their gradient averaging step. And therefore, a new research by Delos and Karin suggests that high-res can improve upon this as it avoids the gradient averaging step and rather performs element-wise multiplication of the feature maps and the gradient. So through our research, through our literature review, we were able to see that there was no application of high-res CAM in the agriculture domain, and therefore there was no comparison conducted with an established baseline techniques such as GradCam++ with high-res CAM, which is a newer and a suggested improvement on GradCam for this domain. So some things that we hope to answer through our research is how this high-res CAM method compares to the established technique GradCam++, and does it indeed provide better explanation? And how does the implementation of this technique actually affect the usability and trust of farmers in comparison to GradCam++? So this is our systems architecture where we can upload an image and this image will be pre-processed and then the class will be predicted through our model and we will be providing a heat map with the classification. The classes that our dataset will be classifying are the leaf spot disease, a healthy class, rough bark disease, and striped canker disease. So in our model training, we used a labeled dataset which is publicly available, and we have carried out few data augmentation techniques in order to improve the generalization. And then we have designed a model with 3 convolutional layers. And then in order to evaluate our model's performance, we have used metrics such as accuracy, precision, F1 score, area under the curve. And in terms of the integration of XAI in our system, we have created 2 functions for high-res CAM and GradCam++ separately. Where for high-res CAM, we have performed the element-wise multiplication of feature maps and gradients. And for GradCam++, we have obtained second derivatives and used gradient averaging. And the reason for GradCam++ in itself being an improvement on GradCam is the use of the second derivative, which gives further detail. We have carried out both quantitative testing and qualitative testing on our system. And our model obtained an accuracy of 81%, a precision of 0.83, a recall of 0.79, and an F1 score of 0.8. And through our ROC curve, we were able to see that all of the classes were received an AUC score, which is greater than 0.9, which helps us to understand that our model is performs reasonably well in distinguishing between the classes. And in terms of the qualitative testing part of our application, we have received feedback from a group of farmers as well as an agricultural estate consultant. And the overall feedback that we received through these reviews was that most preferred high-res CAM heat maps as they found it easier to understand compared to the GradCam++ heat maps. The novelty of our application lies in the integration of high-res CAM in the agricultural domain, as well as the comparison that we have carried out between high-res CAM and GradCam++ in a real-world agricultural setup. So the results that we obtained from our research was that high-res CAM generated more sharper and focused heat maps, whereas GradCam++ was better in images with multiple instances. And this is because it assigns weights pixel-wise when generating the heat map. So we can see that here in the high-res scan heat map, it is more focused on the disease region. As we can see here in our original image, the disease region is here. And in high-res scan, we can see it is more focused. Whereas in GradCam++, it seems to focus, provide focus on the background few instances as well. We can further improve our system research in the future by expanding our datasets diversity and size, as currently it is rather limited. And we can also add disease treatment suggestions, which is also feedback that we received through our qualitative feedback. And we can also extend this research to other spices and crops. In conclusion, we were able to successfully address a real problem existing in Sri Lanka's cinnamon plantation sector by creating a cinnamon disease detection system using AI with the integration of explainable AI. And we also designed and trained the CNN model, achieving around 81% on our specific dataset. And we found that high-res scan produced more focused images, and this led to more trust in those images by farmers compared to GradCam++. And this feedback was validated by the domain experts that we consulted in order to gain the feedback. Thank you for your time and attention.
Thank you, sir. We'll be proceeding with the next paper presentation. I'd like to invite paper presenter Jalali Benabu with the paper title, The Perception of the Ban on the Use of Mobile Phones to Make Voice Calls in Social Settings in Algeria. Sir, if you're ready, then you may start with the presentation.
Thank you so much. Yeah.
Yeah.
Okay with the PPT?
Yes, sir, it is visible.
Thank you. So good morning, esteemed colleagues. Today we explore a critical understudied aspect of digital culture, the perception of the ban on the use of mobile phones to make voice calls in social settings in Algeria. I'm Jalal Ibn Abu, joined by Lila Benounissa and Soumia Thabti from Mascari University, Algeria. Let's delve into how Algerians' rapid mobile adoption contrasts into how evolving social norms. As everybody know, calls, rings, and clicks used in can disrupt social interaction. So mobile phone have some advantages and some disadvantages, and we can find some aspect in versus freedom versus control, connection from versus isolation, usage on public or in a private context. And while this issue is well studied in Western countries, developing countries like Algeria remain under researched. So the aim of this study is to understand how users prefer or perceive the impact of mobile phone in different social settings, and if there are differences in use compared to control variables, which are individual and social characteristics. Generally, answering a call in a public place was often referred to incivility. So interruption of the social interaction it isn't a good thing that we can perceive in society. And in general, every user of phone mobile can adopt three main attitude: fly by disengage completely, suspend by stay but withdraw from the social commitment, and finally persist by remain socially engaged. And peoples have developed many social innovations, such as creation of a small private space within a public space to ensure the minimum privacy necessary to answer calls. And institutions and organizations also have developed some strategies in order to control the users of phone mobile in the social settings, such as creating zone without phone in libraries or passenger compartments on trains, and even messages shown in the cinema to turn off one's phone before the movie. And in addition, vibrate mode and the code of conduct that advocates speaking calmly in a low voice. And the February 6th is declared as the World Day without a mobile phone. The Algerian case, as a beginning, we can give a very important statistic that in Algeria, mobile adoption surged from 5 million in 2004 to 45.5 million subscribers in 2024, with 105% penetration rate. And the Algerian context in this issue is our legs behind Western countries in research and studies. So our study based on a questionnaire, a survey conducted on a sample of 724 users from Mascara and Oran regions in the west of Algeria, with the objective to verify whether personal characteristics which are considered as a control variables influence users' preferences regarding to the obligation to prohibit voice calls in different social situations. And I mentioned that the empirical study is based on the methodology used by Nickerson, Isaac, and Meg in 2008. So in this study, we ask the response for the level of approval of the ban on mobile phone use in different public spaces, namely while driving, in the classroom, in the public transportation, while walking, and in the restaurant and cafeterias. We also ask response to agree with the statement, "I feel lost without my mobile phone." To test the influence of the demographic variables, age, gender, length of usage, a multivariate analysis of variance was conducted using SPSS 22 to assess significant, and the post hoc Turkey also analyzed to identify specific differences in attitude toward a ban. As mentioned in this table, we find that 61.5% of response are workers, 41% have less than 29 years old, and 24.7% have more than 5 years length of usage of the mobile phone. If we take this table also, you can see that there is a positive perception to ban usage of the mobile phone in the social settings, according to the gender, age, family situation, work status, length of mobile phone use. But this result is based only in perception developed by the mean, which is conducted through the Likert scale of 5 level. But we can mention also there is some differences between male and female in the perception between categories of age and family situation, those who are married and those who are not married, those who work, those who don't work. And there is also some differences according to the years of usage of phone mobile. And Mainova test mentioned there is three significant statistical significant effect on the perception of the ban of mobile phone in the social settings. Of the age, of the gender, and of the length of mobile phone usage. And so the post-hoc Tukey test give us some differences between categories of each variables, especially for the age, the gender, and the length of mobile phone usage, and finally the table resume all the results. Here we can see that women are more favored to ban usage of phone mobile in public spaces comparative to men, because in Algeria we have some values, some specific Muslim and Arabic values which expected to be expected from the woman to be maintain or to maintain discretion in the social settings. And so for the age, we find that the persons over 40 are more favored to ban phone by percentage of 1.8 more the youth. And thirdly, phone dependency sweeps results those who feel lost without their device oppose bans regardless of context. Finally, I can see that while this study highlights how age, gender, and phone dependency shape Algerian attitudes towards voice call bans, funding are bounded by regional sampling because the study was conducted only in the Mascara and Oran region, and a focus on the voice communication, and we have to involve the study for other usage of phone, like usage of application and texting. Further work should explore multimodal phone behaviors and test interventions like awareness campaigns, particular targeting youth to mitigate social function. And finally, policymakers could leverage these insights to design context-sensitive norms for public spaces. Sorry. Thank you so much for your attention, and welcome your questions.
Thank you so much for your wonderful presentation. I mean, with Algeria, which are the countries you have actually compared?
I had conducted only the study in Algeria, but the study is based on other study developed in some countries in Europe and in US.
Okay, thank you.
Thank you, sir. This brings us to the end of the session. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 6 to 7 months. Kindly cooperate with the team of ICTIS 2025. I'd also like to thank our session chairs. Just a second. for chairing the session. A token to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you so much for inviting me.
Thank you, sir. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you.
Thank you.
Bye.
Bye.